Welcome to lesson 70. We're going to talk about percentiles and z-scores, and this goes back to our calculation of standard deviation, so you might want to look back a couple of lessons and see that. Now we learned that mu, which is this symbol here, is the mean of a population. So we use that symbol whenever we want to write that out. We don't have to write the whole word mean of a population. We just write this little symbol here. And that would be the little symbol that goes right there. I just forgot to put it in. Hang on. There we go. Okay, so there's another symbol that is the mean of a sample. So for instance, population would be if we took all of the math scores from all of the math classes, like all of the final exam scores from every math class, and we average those out. That would be the mean of a population. But let's say we just took 3 scores from each math class and got the average of those, just 3 at random. That would be what we call the bar X or the X bar, which is the mean of a sample. That would be our sample set. We just took a sampling of the entire population. Does it make sense? So whenever we do like a focus group or a market study, the population is everybody that is involved, not just that focus group, right? Everybody's opinion, not just the focus group's opinion. The sample set would be the mean of that focus group would be the bar X of that group. Now the sigma is the standard deviation of a population. So let's say you did let's say you did some type of medical trial, and it had to do with somebody's heart rate, and you took their heart rate before and you took their heart rate after, the entire population of that study, because that is everybody that's affected by the new drug. That would be your standard deviation of a population. But if you just took like 1 out of 50, for every 50 people that was in the study, you just took random numbers to represent that sample set. That would be your S sub X, standard deviation of a sample. So S sub X is the standard deviation of a sample set. So you can find the mean of a sample set, and it's the bar X. The S sub X is the standard deviation of a sample. I believe I'm saying that right. Let me double check. Yes, S sub X is how we would say that. So remember our standard deviation map and how it works. We have our mean right here. One standard deviation on either side of the mean is going to give us 68% of the values in that population. And then 2 standard deviations on either side of the mean is going to give us 95% of those values or the data. And then 3 standard deviations on either side of the mean should give us 99% of all of the data that's collected on whatever that population is. And anything outside of that 99% or well outside of the range of those 3 sigmas or those 3 standard deviations is outliers. Okay, remember that? So that's our little map that we went by. So now how do we calculate this normal curve? How do we look at that? We have a formula that we use to calculate the normal curve of an equation, and it is highly complicated, and you have to have a calculator to do this, and you could grind it down on paper, I'm sure, but it would take you a very long time. And this is how this would work. But we typically allow the calculator to do this, and what we calculate ourselves is called the z-score, and the z-score is going to be inside the exponent of this equation, and that is what the z-score is. And it is going to be the x minus the mu divided by the sigma. So the sample minus the mean of the population divided by the standard deviation of the population. And when we find that z-score, we use something called a standard normal table. Now, this is just a sample. There are tons of numbers in between each one of these. We just got the whole numbers here for the sake of a sample to do the problems that we have to do. So if you go and look this up online, there are a ton of PDFs. I'll download one and put it in your materials file for class. But a standard normal table is what we use to help us find all of this. So we don't have to do all of those calculations. So that being said, let me show you how to use a z-score, what numbers you plug in where, through some example problems, and then how to use this standard normal table. So let me prep the page here for us. So here's how we would use a z-score, in 70.1, our problem states. The mean weight of babies born in a hospital for 7 years was 6.8 pounds with a standard deviation of 0.8 pounds. If the distribution of the weights were approximately normal, what percent of the babies weighed less than 6.4 pounds? So 6.4 is going to be our sample, or our the number that we're looking for, right? That's our sample set. So we would put that number in first. Remember, that's our x minus our mean, right? So x minus our mean divided by our standard deviation. So our x is 6.4 and our mean is 6.8. And we divide that by 0.8, which is our standard deviation right here. You highlight that information for you. The mean weight was 6.8 pounds with a standard deviation of 0.8. If the distribution was approximately normal, what percent, so we're looking for a percent of the babies weighed less than 6.4 pounds. So 6.4 pounds is where we're going here. So that's the information you're going to look for in the word problem. Now, the way that we read that table is we look at, we put in our information, we do the calculation, and we look at everything before the decimal on the left-hand side, which is going to be here. And because it's a -0, it's actually just, less than 0, right? It's -0.5. But because we have numbers that are less than 1 that are negative, we have to have the -0. So we look on the -0 row, and then we look for the 0.5. Then we look for the decimal value, and that we look from the top down. And where those two overlap, that is going to be the percent. And the percent is going to be in a decimal form, so you have to shift the decimal. Originally, it was 0.3085. But we multiply that by 100 to put it in decimal or in percentage format, and that becomes 30.85%. So it's not super difficult. You just have to understand what you're looking for and how to put it in. So let's try another one. So in this problem, we use the information from example 70.1, and it says, for example 70.1, what percent weigh between 6 and 7 pounds? So I pulled our standard deviation from the first problem and our mean. Our standard deviation is 0.8 and our mean is 6.8. So first we find the z-scores for both of those numbers. So I started with 7 pounds. Now 7 minus 6.8 is 0.2, and 0.2 divided by 0.8, you can just do it on your calculator if you want to double check. So 7 minus 6.8 is 0.2 divided by 0.8 is going to be 0.25. So 0.25 is going to be our z-score, and we look on our standard deviation chart for our percentages. We're just going to pull the decimal first. So I'm going to look, let me get my highlighter here, and I'm going to look for 0, positive 0, and then 0.25. Let's see. 0.25 is not listed, but 0.2 and 3 are listed. So we're going to go halfway in between these two numbers here. So these are the two numbers we're looking at, and we're going to use this one and this one. We're going to take in between those two numbers. So we're just going to add them together on our calculator and then divide them by 2, and that's going to give us our number. So 0.5793 plus 0.6179 equals divided by 2. So that gives us halfway in between. So that's 0.5986, and that is not what we have in the book. The book has a different percent. Oh no, it does have that. Sorry, I'm looking in the wrong place. So this is exactly what the book has, 0.5986. So that is what we're going to write down for 0.25. So 0.5986 is going to be this value here. Let me get my pen back. 0.5986. That's our percentage. And then you see the reason why I did that, because we didn't have a 0.25 listed. So I went halfway in between those two numbers there to get that. All right, so that gives me my percentile, 59.86% for 7 pounds. So I've got to do the same thing for the 6 pound. So I am going to pull up my calculator again, and I'm going to say 6 minus 6.8, which is negative 0.8. I'm going to divide that by 0.8, and that gives me a negative 1. So negative 1.00 is the way I would write that. And if I look here, I get negative 1 and negative 0. So that is going to be the number that I use right there. So 0.1587. That is going to be my percentage there. So now I have to find the percentage of babies weighing between 6 and 7. So we just subtract the percentile. So I'm going to take this 7 minus the 6, and that's going to give me the difference between these. And I'm just going to do that on the calculator to make life easy for myself. So 0.5986, and to save you guys a little time, 1 minus 0.1587, and that's going to give me 0.4399. So 0.4399 times 100 is going to equal 43.99% is the answer to this question here. That is the percent of babies that weigh between 6 and 7 pounds. All right, so that is all you're doing. You're going to pull the information and just plop these numbers in where they go. Remember, the formula is X, that's your sample, minus your mean of your population, divided by the population standard deviation. And that's going to give you your z-score. And then you use the z-score to look it up on your table. So let's do one more. All right, so for this problem, I want to see if you can solve it yourself first. So I want you to pause the video and read the problem. In the same hospital, what percentage of babies weighed more than 7.2 pounds? And I've given you your mean and your standard deviation from the same problem. So pause the video and see what you get. See if you remember. And then you can press play and see the answer. So if you got 69.15%, you got the wrong answer. The correct answer is going to be 30.85%, and I want you to understand why. That's because on this, think about the number line and how the chart is written on the number line. This number is going to be 7.2 pounds and less because our mean is 6.8 pounds. So it's looking at that as the percentage. So when you look for 7.2 pounds on your number line, right, You've got your mean here, and 7.2 pounds is here. So 7.2 and all the rest, everything less than that is going to be this 69.15%. So everything greater than that is going to be 30.85%. So if you got 30.85%, congratulations for thinking it through. The trick to that question was this part right here where it said weighed more than 7.28 pounds. So you have to be careful how you read the problem. So don't let little things like that trip you up. All right, so let's see if we have one more. We do not. That was the last one. So you have to remember that this is on a number line. So when it's asking you for a difference or for more than or less than, think about the number in relationship to the mean and what that means. You know, even draw your number line if that's going to help you understand what the question is specifically asking for and how you need to adjust your answer if necessary. All right, so I hope that makes sense to you in regards to what we're doing here and what we were looking for. If it had said what percentage of babies weighed less than 7.2 pounds, then 69.15 would have been your answer. But it said more than 7.2 pounds. So we wanted on the other side of 7.2, the other part. So that's all I have, again, for lesson 70. Not a difficult lesson, I don't think. You just have to pay attention to the wording of your word problems and the language that's being used. And I'll see you in lesson 71.